Mr. Monroe will tell you about water and ice. Ms. Ramirez will talk about the wind. Ms. Fuller will teach us about gravity, and Ms. Nash about igneous activity. During this field trip, you cannot verbally speak to us, but you can ask questions by going to www.tiny.cc/EEC question space answer. And now, Mr. Monroe is going to tell you about water and ice.
Good morning, students. My name is Mr. Monroe, and we're going to be investigating how water and ice can change our land. In fact, they are very active forces in what we call earth processes. And those earth processes that we're referring to is erosion and deposition. Erosion is the transport of materials by some agent moving it around, and deposition is the depositing or the laying down. Now, what I'm going to do is get right into the presentation by sharing my screen with you all. Bear with me just for a minute here. Erosion and deposition, agents, forces, and results. What caused this? If we look at these images, we can see that there was some type of force or an agent that created these images. What is erosion? You know, erosion is the moving of rock material from one place to a new location. Three processes must take place: the detachment of particles, the lifting them, the transporting them. And you know, agents of erosion are these: flowing water, moving ice, waves, gravity, and wind. And of course, there'll be another teacher talking to you about that agent that we call wind. You know, sand is composed of small pieces of rock that have been weathered from a parent rock or eroded and deposited somewhere else. Now, there'll be another teacher focusing on this, but wind wears away rocks and is responsible for the creation of deserts such as the Sahara or the Gobi Desert. And I'll let her get into detail about how wind acts as an agent. Now, when we talk about water, what is water erosion? Water is the most influential force in erosion. It's the strongest force of erosion found on our planet. It moves materials, it transports large objects with fast-moving streams, and it wears away rock. Rivers, lakes, and ocean can cause erosion in concert with gravity and with other agents such as wind. In this image, we see that there's a bit of erosion going on in the image. We see that there's rocks that are probably being moved and that soil, and it's creating a widening of the stream. Eventually, that will be tremendously wide. What is wave erosion? Well, waves create a condition of relentless pounding. It erodes the softer, weaker rock first. Harder and more resistant is left behind. And it can take over 100 years to erode a rock to sand. Energy of waves and chemicals contained in the water erode the rock off the coastline. Gravitational pull, or gravity, is in concert with that mass movement, meaning that we've got a downward movement of rock and sediments due to the primary force of gravity, streams and glaciers move material from higher to lower elevations. And this occurs continuously on all slopes. It is said that ice in the form of a glacier area, which is a vast area that is made up of ice, as it moves from a higher elevation to a lower elevation, can scar and create different landforms. In fact, it is said that Long Island, the island that is up there at New York, was created by a glacier, and it was caused by a process that is called glacier till, meaning that piles and piles of material was moved, and when the glacier slowed down and eventually melted, it left that pile there, and that actually is called a moraine. Ice moves and carries rocks, grinding the rocks beneath the glacier. Plucking occurs when water enters cracks under the glacier. Freezing, breaking off pieces of rock that are then carried by the glacier. An abrasion starts to happen. Cuts into the rock under the glacier, sometimes smoothing and polishing the rock surface. What is deposition? Deposition is the laying down of sediment that has been transported by a medium such as wind, water, or ice. The process of erosion actually stops when the moving particles fall out of the transporting medium and settle on the surface. Speed of the medium slows or the resistance of the particles increases, the balance changes and causes deposition, the laying down of those particles. Speed can be reduced by large rocks, hills, or vegetation. Now, just like I said before, there'll be someone come along and talk about the effects of wind as an agent. So I'm going to skip this part. Now, water deposition. Running water enters a large, fairly still body of water, and its speed decreases. As the speed of the water decreases, the water's ability to carry the sediment also decreases. Deposited in streams, rivers, and oceans, running water deposits sediments where the flowing water can no longer move them. Largest particles are deposited near the shore. Increasingly smaller particles settle out farther from the shore where the water is calmer. We can see that the water in this image is moving pretty fast. Once it enters this area, it slows down and it starts depositing the material that it was carrying. Most likely is going to be deposited in this area here. Deposition of ice. Glacier flows of ice become slower when the ice begins to melt. Depositing are deposits left by glaciers. Outwashers are deposited similar to those left by rivers. Large chunks of broken rock deposited at the base and sides of the glacier as it melts and recedes are called moraines. When the glacier ice melts, smaller material is carried by the rivers. And that's why I mentioned earlier about the moraines, and Long Island, New York is considered to be a moraine. What's the difference? Weathering. Think of weather wearing rock down. Erosion. Think of a road and traveling. Deposition. Think of depositing money in a bank. So at this point, I'm going to stop sharing my screen because I've basically run out of time. And I'm going to turn it over to Dr. Gorman. So if any of you have any questions, maybe he can answer those for you. You guys have a good day today.
Thank you, Mr. Monroe. What is the volume? A student asked this question. What is the volume of water when it turns into ice? When the water gets converted to ice, its volume increases as mass of substance remains the same. As a result, density of ice is less than that of water. Now, that is one of the few substances that when it gets cold and freezes, it expands. And you may have experienced that during the recent cold weather that we've had, or you may have known somebody that their house was flooded because their pipes burst. The water in those pipes kept expanding, and the copper or PVC pipe around them couldn't take that pressure, so they ruptured it. When it melted, all the water ran out into the houses. Several examples of that. Now, you know, science will solve a problem. They're making now a PEX pipe that's supposed to expand when water gets cold and freezes, but it will not burst. All right, now we're going to let Ms. Ramirez tell us about the wind.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about wind and its ability to erode and deposit sediment. So before we get started, I just want to show you guys something cool that I got. So this is actually a tumbleweed, and I picked it up on my trip out to the Panhandle over spring break. But I was so fascinated by all those tumbleweeds that were just rolling around out in West Texas, I decided to get me a souvenir. But that's a great example of how wind can pick up things and move it. So not only can wind move plant material or tumbleweed, but can also pick up sediment like sand and soil. And I'll show you guys some examples that I encountered when I went out to West Texas of some of those dust storms that they have there as well. So let me go ahead and share my screen with you guys, and we'll get started on our presentation. So today we are learning about erosion and deposition through wind action. So I have a couple of essential questions for you guys. Hopefully by the end of this segment, you guys will be able to identify and answer these two questions. The first question is, how does wind change Earth's surface? And the second question is, explain how sand dunes are formed. So we're going to go ahead and jump on into it. So here's some images of sand dunes, and a sand dune is simply a land form composed of wind-driven sand, and it typically takes the form of a mound or a hill. And we actually have sand dunes here in Texas. So there's a Monahans Sand Hills State Park here in Texas, and that's in Monahans, Texas. So if you've ever made that trip down to El Paso, you probably passed through Monahans. I've never been there, but I have passed through it. I should have stopped, but you can actually go sandboarding there down those dunes. And then if you've ever gone near Galveston or near the beach, there's also coastal sand dunes as well. So as you take a look at those pictures, think about how does vegetation affect sand dunes. So do some research on how sand dunes might be different in a dry, arid region versus near a beach or coastal region. And then, so let's talk about how those sand dunes are formed. So we know sand dunes are formed by erosion and deposition. So let's take a look at this diagram here. So as the wind is blowing, sand is being moved or eroded. So eroded just means to move. So the wind is picking up those sand particles and it is moving it upward. Eventually that sand is going to move upward to what's called the crest, kind of like the peak of the sand dune, and it's going to roll down the opposite side called the slip face. Eventually it's going to stop moving and it's going to be deposited or dropped. So deposition just is the dropping of that sediment. So the windward side is the side from which the wind is blowing, and the leeward side is the opposite side. So we can see how wind is eroding or moving sand, and then it is being deposited on the opposite side. Now think about what force pulls the sand down the other side of the slope. And I'll give you guys a hint. It's that same force that if you take a moment to stand up, it's that same force that is pulling y'all back down. So through the force of gravity, that sediment is going to roll downward down that slip face and eventually be deposited or dropped. So wind erodes or moves sand and then deposits it or drops it in a new location, and that is how we get those sand dunes forming. And then here's an example of that motion that's involved in the formation of sand dunes, and we call it saltation. And that just is Latin for leap. So essentially, as the wind is blowing those sand particles, it's lifting those small sand grains off the ground. Eventually, they're going to drop due to gravity, but when they drop, they're actually hitting other sand particles, causing those other sand particles to jump up due to the impact. So saltation is simply that jumping motion of sediment due to wind. So saltation plays a big role in dune formation. Now, saltation is not the only type of movement caused by the wind. So take a moment and examine this diagram. Think about what are some other effects of other forms of wind action. So we have suspension and creep also. So take a look at the diagram and take a moment to maybe think about or discuss how are suspension, saltation, and creep different, and what types of landforms can each of those motions cause. Also think about what do you notice about the size of the particles involved in each of those motions. And again, feel free to pause the video to allow time for discussion and observation, but I'm going to go ahead and just go ahead and explain it with you guys. So we have noticed that the smaller particles are involved in suspension. Now that makes sense because the smaller particles are lighter, so the wind's going to be able to carry them and lift them. So sometimes if you ever watch the news in the mornings, they might have like ozone action days or like air quality days where they tell us about the air quality. So through suspension, particles, sand particles, dust from all around the world can be carried vast distances. So that's why it's important to keep an eye out for those air quality alerts that meteorologists give us. So that's suspension. We talked about saltation with kind of the jumping motion of the sediment, and that's involved with sand dunes. And then there's also creep. So notice creep involves the larger particles, and essentially they're kind of just being pushed or rolled along the bottom of the ground. Now here's, if I were smart, I would have taken a picture, but this was a dust storm that went through Lubbock, Texas on January 30th of this year. And you can see how crazy windy it was, and look at all that red clay that's just being blown around in the wind. And actually on the way back from our trip during spring break, we got caught in one as we were driving, and it was so crazy because we couldn't see anything on the highway, and obviously window wipers weren't working. So that was super exciting because I had never driven through one of those before. But that's a great example of wind moving sediment vast distances. And something similar, the Dust Bowls in the 1930s, you guys have probably heard about that in textbooks. It affected the Panhandle and Great Plains area. And during the Dust Bowl, 122 tons of dirt an hour blew through Lubbock, Texas. So the wind can carry sediment, a lot of it vast distances. And the Dust Bowl was likely caused due to drought, high temperatures, and then poor agricultural practices back in the day. But of course, to help slow down the effects of dust storms or sandstorms, people can plant trees for windbreaks. They can also help to restore grasslands, because if you have grass or vegetation, it's going to hold a lot of that sediment in place. And again, think about what type of motion causes dust storms. So remember, we talked about saltation, we talked about the creep, and then we talked about suspension. So hopefully, you know, suspension is what causes those dust storms, that motion. And then not only can wind erode or move sediment, and not only can it deposit or drop it, but it can also weather or break down rock. So there's some pretty interesting geological shapes that you can find throughout Texas. This is in Waco Takes State Park near El Paso, and it's this weird looking arch. But wind, this is caused from wind weathering. The wind can actually be abrasive. Think of like sandpaper. So as the wind is carrying sand, those sand particles are slowly kind of like abrading or weathering away particles of rock. So we call that abrasion. And then I have a quick challenge question for you guys. We didn't have time to go into detail about all these other cool landforms, but I would like for you guys to research other aeolian or wind landforms and explain how weathering, erosion, and deposition are involved. So here we have an example of a Loess bluff. We have desert pavement. Here's a cool, they're called ventifacts. This one happens to be in Algeria. And then something new I learned, yardangs, these interesting elongated structures caused by the wind, and then deflation, hollows, or blowout dunes as well. So take time to research some of these interesting landforms caused by the wind, and maybe see if you can find examples of some around the world. So I'm going to stop our screen share and just really quick a reminder to help you remember those vocabulary terms. So weathering breaks rock, erosion takes the rock or moves it, and then deposition drops it. So we have weathering breaks it, erosion takes it, and deposition drops it in a new location. So we're going to give it back to Dr. Gorman to answer any questions.
Thank you, Mr. Maris. And the question is wind blowing sand weathering or is it erosion? Okay. Sand dunes form when the wind blown sand starts to pile up. Sand is eroded from the upwind side of the dune and deposited on the downwind side. So the whole dune gradually migrates downwind. Thank you, Ms. Ramirez. And Ms. Fuller is going to tell us about gravity.
Good morning, boys and girls. We're going to review what you learned in 4th grade about soil formation. And you learned that there were 5 different factors that helped form soil. The first one being the parent material. Now, up here in the Dallas area, our bedrock is this Austin chalk. So when this gets weathered, this forms the sediment for our soil. The second factor is organisms. So because we're on the Blackland Prairie, our native organisms are things like grasses, little blue stem, big blue stem, bushy blue stem, Indian grass, switchgrass, that sort of thing. And that was an oak leaf I just showed you. We do have a post oak savanna across the street. Then the second thing is climate. So what kind of climate is the soil in when it is forming? Is it wet? Is it dry? Is there a lot of rain? Is there not so much rain? What's the humidity, amount of sunlight, all those parts of climate. The next one would be time. Here's our upside down Judy clock. Time has a great deal to do with the formation of soil in that it takes a long time. It takes about 500 years for 1 inch of soil to form. And then finally, we have something called slope. Well, in our area, because we're on a plains type of area, our area is relatively flat. Now, slope is another way of saying relief or topography. So here where we are, as the sediment, broken pieces of rock, as it builds up, it essentially stays in the same place. But what happens when you don't have a relatively flat or even rolling topography? What if you have a very steep topography? What happened there? Well, what happened there was gravity. Gravity eroded the sediment simply because of the slope of the land. So let's talk some more about gravity. So let me share my screen with you. And gravity, not gravy. All right, so there's Isaac Newton, probably one of the greatest minds in physics, right after Leonardo da Vinci. He was a brilliant man, and he's given credit for describing gravity. He didn't invent it, but he did put words to it so that we could understand it. Now those are apples on the ground. Supposedly an apple fell on his head, but I doubt that story. Oh, and by the way, this actually happened also during a plague, like not like the one we have. That one was different. But he wasn't at university. They'd sent him out to the country to live so that he would be away from the plague. And that's when he came up with his 3 laws of motion and also gravity. So the picture on the far right-hand side shows some astronauts in training, and they are in a gravity-less environment. They're kind of floating around. So let's think of 2 essential questions. Number 1, how does gravity cause erosion and deposition? I just showed you an example of erosion. How can gravitational erosion be prevented? And what you've got there, those 2 little graphics are pictures that if you go to an area like Rocky Mountain National Park, for example, they have a lot of rock fall there. And so they post these signs on the road so that people will know to look out for the rocks falling, because gravity is going to pull those rocks down and it may or may not hit your automobile. So here's some gravity in erosion. And you see these 2 pictures here, and you see how that gravity has pulled this sediment down in a pretty spectacular way in both of them. And I suspect what happened in both was that there was a loss of vegetation, there was a big rain event, the sediment became very loose, and gravity pulled it down. Now, when it reached the bottom, then we call that deposition. So the gravity was active in the erosional part, but also in the deposition, pulled it to the ground. So this is something called slump. And you see, if you look here on the side of this little cliff, there's got some grass growing, and the ground itself just sort of gave way and slumped down. And we see this a lot in our area. If you'll think about over by Mountain Creek Lake, that area over there, the soil is formed from a very mobile sediment called Eagle Ford Shale. When it gets full of water, it falls apart and gravity just pulls it down. And one day it'll just be a grassy slope, grassy knoll, and then the next day it'll look like this, where everything is slumped down. There's another type that's a little bit slower called creep. And in creep, you see that if you've ever been on the side of a hill where there were fence posts, and some of the fence posts were farther down the slope than others, that's because that particular place just crept down. Gravity pulled it. Here's another example of a place where gravity has pulled the soil away from the roots of the tree. And this is a real steep slope. It's practically vertical. And so if you'll look at the bottom where those little bushes are, those little shrubs, you'll see a lot of sediment built up. And that's the deposition part. Now, when we talk about gravity and deposition, and Mr. Monroe talked about this when he was talking about moving water being the #1 agent of erosion on our planet. Water is very powerful. 2 feet of water can pick up your automobile and take it off the road. And it can move a tremendous amount of very heavy sediment. But as it loses energy, as it slows down, it starts dropping the sediment, and it drops the big pieces first because they are the heaviest. So if you think about the Mississippi River, as it slows down there in New Orleans, as it begins to enter the Gulf of Mexico, it's going to drop the gravel, and then it's going to drop the sand. And finally, as the water enters the Gulf of Mexico, it's going to enter with a lot of silt suspended in it, which in turn, in time, gravity will pull that silt, even as tiny as silt is, will pull it down. So is there a way we can prevent gravitational erosion? Now, this is a picture of a hiker in the mountains, and you'll see over on the right-hand side, the grasses. It's very important when you go to a national park or a state park that you follow the recommendations or the signs that tell us what to do. Now, let's take Rocky Mountain National Park as an example. There will be signs everywhere on the trails that say, stay on the trail. Because if you wander off, the vegetation does not have a lot of soil there because of the slope. And so the little soil that's there that the plants are in, if you trample the plants, kill the plants, the soil will follow gravity and will roll down the hill. So it's very important that we try to protect our parks, both in the lowlands and in the mountains. So let's talk about some steps to prevent erosion due to gravity. Number one, be careful and do not dislodge rocks when climbing or hiking. I have a family member who is a rock climber, and she has a friend who was killed by someone who dislodged a rock and it hit this person in the forehead. So gravity doesn't take in consideration our feelings. It just happens. So you have to be careful. You have to be responsible not to, certainly do not throw or heave rocks, but also be careful when you hike or climb that you don't knock rocks down into the person behind you. Stay on marked trails. Don't wander off trail. That causes erosion. It's very harmful to the ecosystem, not to mention the fact that the soil, the sediment, will roll down hill due to gravity. Don't build on soil that's mobile, such as the Eagle Ford Shale. And you think about that area over there on Loop 12 by Mountain Creek Lake. There are a lot of houses and roads over there that are literally falling off those hills because the soil itself can't sustain it and gravity is pulling them down. Landscape with plants that have deep roots. You live in the Blackland Prairie. The Blackland Prairie, it's the most endangered ecoregion in the United States, or most endangered ecosystem in the United States. We used to be covered in grasses. Prairie grasses have very, very long roots. Most of the plant is underground, holding the soil in place. It's one of the reasons why the center part of our country has such rich agricultural grounds, is because of those prairie grasses holding that soil in place for thousands and thousands of years. So take a tip from nature and plant things that will hold the soil in place. And number 5, do not overuse an area. So if you have any questions about gravity and how it affects us, Dr. Gorman will be more than happy to answer your questions for you. Thank you.
Thank you, Ms. Fuller. And I was, had some students, I used to teach school in that area over by Mountain Creek Lake, and I had a bunch of students in the 7th grade, and they didn't come back into 8th grade, several of them, and I asked some of the students about them, and apparently they lived in an apartment complex over behind the, maybe a Kmart store or something over there, and it was built on the kind of on the side of one of those hills over there, and it had gotten so bad, it had slipped so much because of gravity that the pipes were coming loose, and the city decided that it wasn't safe anymore. So, you know, they put out about 100-something families, had to go find another place to live because somebody built that on an unsafe area. Now the question came in, okay, gravity is really important in erosion and deposition, but can you name another example of where gravity is beneficial to people? And yes, it keeps the planets in orbit around the sun. If it were not for granted, we'd just sling off into outer space, either away from the sun, where we would freeze to death, or towards the sun, where we would suffer another example of demise. Now, Ms. Nash is going to tell you about igneous activity.
Hello, welcome to my class. Welcome to my classroom. So today we're talking about igneous activity, which means volcanic activity. So we don't have any volcanoes close by us. So let's look at some pictures and think about volcanoes and how they change the surface of the planet. And where to go? There it is. Okay, so volcanoes are formed by the magma coming to the surface, okay, and escaping from the center of under the earth. Most of our volcanoes near us are in this ring of fire where convergent plates, okay, are smashing together and weakening the whole system. And then we have all these volcanoes. Others are on these what we call hot spots. That's Hawaii, across here, where the crust is thinning and stretching. So most volcanoes are under the water and they're see, forming here, the gas coming out, lava coming out, forming finally an island. It's more and more over a long time, or fairly quickly in some cases, it forms an island. Okay? So the Hawaiian Islands are an example of islands formed like this. Okay? So we're forming new land. One of these islands in New Zealand called White Island last year was really deadly. So tourists were going out to see the volcanic eruption, being a tourist, and then suddenly the whole thing exploded and more than 50 people died. So it can be a kind of dangerous tourist destination. There are three kinds of volcanoes. We always think about the perfect cinder cone, like this Arenal volcano in Costa Rica, perfect cinder cone. That's one kind. Other kinds are shield volcanoes and stratovolcanoes. So shield volcanoes like Mauna Loa in Hawaii, they're huge. Okay, it's coming at 17,000 meters from the sea floor and 13,000 feet above sea level. So amazingly, just huge. So these tend not to be too explosive. They have slow moving lava, okay, and it erupts almost continuously, one of the most active volcanoes on the planet. And it's forming lots and lots of new land. As that lava comes out and cools, okay, it forms rock, and then eventually it breaks down into, by erosion, it breaks down into soil. So the most dangerous kind are ones like Mount St. Helens. They're called stratovolcanoes, and they tend to be very huge and they can explode like Mount St. Helens did in 1980. And I visited there maybe 10 years later. It was still amazing to see the damage. The eruption killed 57 people, and of course, all the animals leveled the forest, a pyroclastic flow. And of course, it left a changed landscape behind. This is the ash, okay? Deadly gases and ash. Another example of a stratovolcano is in Italy, Mount Etna, a very famous one. And the interesting thing here, people have been living there for hundreds and hundreds of years, right in the shadow of a pretty dangerous volcano, which is pretty active. Why are they there? Because that soil that forms from the eroded lava over hundreds of years is very rich soil. It's great for agriculture. So people like to farm around that volcano, even though it can be a dangerous place to be living. Okay. Hopefully you have some warning you can live quickly. Another stratovolcano is Popocatépetl near Mexico City, and that name means smoking mountain in Aztec. So both Mount St. Helens and Popocatépetl are in the Pacific Ring of Fire, where those convergent plates are smashing together. So Iceland is again having an eruption currently. There's an active eruption in Iceland. You can look that up. There's a mid-ocean ridge there forming their volcanoes. There are active volcanoes in Texas. You can find some extinct ones, in kind of barely see here. Probably an old sealed volcano right there out in central West Texas. That's all we've got here in Texas. So, okay, yeah. So I'm going to stop sharing here and we're going to make our own little volcano and think about the kinds of rock that forms a volcano. So all that new land, okay, from the volcanoes can be different kinds of rock. So I've got my model volcano here, which is not a real volcano. And there we go. Okay, here's our erupting volcano. So as that lava comes out of the volcano, it cools. And depending on where it cools, we get different kinds of rock. So like Mambo is that slow moving lava, we're gonna get what we call scoria. Okay. So it's got holes in it. If you come to visit, you can see all the holes in this rock. It's pretty light because of the holes. If it cools slowly underwater, maybe it forms granite. Okay, we have a lot of granite in Texas, okay, from those ancient volcanoes. My favorite is obsidian. So this cooled really quickly in water, and it's so amazing. It's like glass, and it's really sharp. And those Aztecs there used to make knives out of it. Okay. Sharp, you make a knife out of it. And then kind of the most amazing kind is pumice. So this cooled quickly in the air. And the amazing thing about this one is it will float. So if you think a rock can't float, it can. This here, you see my floating rock. You see the floating rock. So all the others, even this one with all those holes. So you see the bubbles coming out where the air was inside that rock. So that one erodes pretty quickly, partly because it's got all those holes in it. It will erode really quickly. Granite is really hard. And of course, obsidian is really sharp and hard also. But that scoria will erode pretty quickly. Okay? And that's one reason it causes that really, makes that really rich volcanic soil. Okay, people like to farm. So volcanoes are really important in forming the rocks that then erode and make soil. And we live on our planet with our volcanoes around us. So if you have any questions, Dr. Grover would be glad to answer.
Thank you, Ms. Nash. And the question is, was any igneous activity or volcano ever used in a movie? And yes, they made a movie in 1968. It was an action movie, and it was called Krakatoa, East of Java. And if you'll read about it, when it gets down to the plot, it says it's historically inaccurate. And the reason that it's inaccurate is because the Java is actually, the Krakatoa is actually west of Java. And the interesting thing about Krakatoa is that was the loudest sound ever heard on the earth. It was heard distinctly over 3,000 miles away, even more so than the nuclear bomb and all that they set off. So yes, igneous activity has been in the movies, and it was inaccurate. Okay. And now I'm going to share my screen. During this virtual field trip, students compared the roles of erosion and deposition through the actions of water, wind, ice, and gravity, and igneous activity by lava, and consistently reshaping the Earth's surface. Mr. Monroe told you about water and ice. Ms. Ramirez talked about the wind. Ms. Fuller about gravity, and Ms. Nash just covered igneous activity. Thank you. How did we do? Teacher, if you would, go to www.tiny.cc/EEC feedback, fill out a very short form and send it back to us. We would appreciate it. Thank you guys so very much for joining us today. Hope you have a great rest of the day. But more importantly, I hope you have a great rest of your life.